Welcome to section 5.1, Arrays. In this lesson you will learn how to store many values under one name. Let's get started. Welcome back. So far, every variable you made holds a single value. One number, one character, one thing. In this lesson, you will learn how to store many values under one name. The tool for that is called an array. Let's see what an array is and how you use one. This is the plan for this video. First, you will learn what an array actually is. It lets you store many values of the same type under one name, all sitting together in one block of memory. Next, you will see how to declare an array and how to reach the values inside it. The indices start at 0, and you use an index to read or write any element by its position. Then you will fill an array with values and loop over it. You will use this pattern to add up numbers, search for a value, and find the largest one. After that, we talk about a real danger. C does not check your index. If you go past the end of an array, the result is undefined and your program can misbehave. Finally, you will learn how to find an array's size, how to pass an array to a function, and how to avoid the common off by one mistake. Why do we need arrays? So far, every variable holds a single value, one int for a temperature, one double for an average. That works fine when you have just a few values, but what if you need to store 100 test scores? Declaring score 1, score 2, all the way to score 100 is not just tedious. It is unworkable. You cannot loop over 100 separate variables. There has to be a better way, and there is. So what is an array? An array lets you store many values of the same type under a single name. An array is a fixed size, contiguous sequence of elements of the same type. The elements are reached by their position, which is called the index. The size is set when you declare it, and it cannot change later. So instead of score 1 through score 100, you write int scores, square brackets 100. Then you reach each value by its position. Now let's declare an array. An array declaration looks like a normal variable declaration, but with a size in square brackets. Int scores, square brackets, 5, semicolon. This creates an array named scores that holds 5 int values. The number in the brackets, 5, is the size. That is the number of elements it can store. And just like ordinary variables, a local array that you declare without giving it values holds garbage. Each slot holds an unpredictable number until you store a real value there. An array lives in one unbroken block of memory. This is scores, with 5 int slots sitting side by side. The first slot is index 0. Its value is 90, and it lives at address 1000. Next to it index 1, value 85, at address 1004. That is 4 bytes after the first slot. Index 2, value 92, at address 1008. Index 3, value 78, at address 1012. Index 4, the last slot, value 88, at address 1016. Look at the addresses. Each one is exactly 4 bytes after the last, because one int is 4 bytes. That is what contiguous means, and it is what makes indexing fast. Now how do you reach a single element? Each element has a position called its index, and this is the most important rule to remember. In C, indices start at 0, not 1. So an array of 5 elements has indices 0, 1, 2, 3, and 4. The first element is at index 0. The last element is at index 4, not 5. The index, also called the subscript, is the 0 based position of an element. For an array of size n, the valid indices run from 0 through n minus 1. The expression array square brackets I reaches the element at index I. Let's use indexing in a real program. First, we declare an array of 5 ints called scores. Then we store values. Scores at 0 gets 90. Scores at 2 gets 92. Scores at 4 gets 88. Each scores at I behaves exactly like an ordinary int variable. You can assign to it, read from it, and print it. We print scores at 0, which is the first element, and scores at 4, which is the last. The output shows first 90, then last 88. You can give an array its first values right when you declare it, just like a regular variable. Use braces with a comma-separated list. Int scores, square brackets, 5 equals, brace, 90, 85, 92, 78, 88, brace. The first value goes to index 0, the second to index 1, and so on. There are 3 handy tricks. First, partial initialization. If you list fewer values than the size, the remaining elements are automatically set to 0. Second, you can zero the whole array by writing equals, brace, 0, brace. Third, you can leave out the size. If you give an initializer list, the compiler counts the values and picks the size for you. This is the array we will walk. 5 values, 90, 85, 92, 78, and 88. The loop variable I will visit each one in turn. First I is 0, scores at 0 is 90. We read it and add it to the sum. I++, now I is 1, scores at 1 is 85, add it to the sum. I++, now I is 2, scores at 2 is 92, add it. I++, now I is 3, scores at 3 is 78, add it. I++, now I is 4, the last index, scores at 4 is 88, add it. I++ makes I 5. The test, I less than 5, is now false, so the loop ends. Every element was visited exactly once. A very common task is finding the largest element. The strategy is simple. Assume the first element is the largest, so we set max to scores at 0. Then we scan through the rest. If we find something bigger, we update max. 2 details matter. The loop starts at I equals 1, not 0, because we already used scores at 0 to set max. And we set max to a real element of the array, not to 0, so it still works when every value is negative. The output is highest, 95. This is scores, a 5-element array. The valid indices are 0, 1, 2, 3, and 4. All 5 cells are real memory that belongs to the array. Now what about scores at 5? There is no 6th cell. This red slot is one past the end. It holds unknown memory, shown as 3 question marks. When you write scores at 5, C does not stop you. It silently reads this out-of-bounds slot. That is undefined behavior. Anything can happen. Let's be clear about how dangerous this is. Accessing scores at 5 on a 5-element array compiles without any error. When you run it, the value is unpredictable. You might see 0, or a random number, or the program might crash. This is called undefined behavior. The C standard says anything can happen. Out-of-bounds writes are even worse, because they silently overwrite memory that belongs to other variables. So the rule is simple. Always check that your index is within bounds before you use it. Sometimes you do not want to repeat the size as a magic number all over your code. The sizeof operator helps. Sizeof on an array returns the total number of bytes it takes up, not the number of elements. So to get the count, you divide the total size by the size of one element. Sysioff scores divided by Sysioff scores at 0. The output is elements 5. Here scores holds 5 ints, each 4 bytes, so Sysioff scores is 20 bytes. Sysioff scores at 0 is 4 bytes. 20 divided by 4 is 5. The nice thing is this count adjusts by itself when you add or remove values. You can pass an array to a function. In the parameter list, you write empty square brackets to say this parameter is an array. Look at this average function. It takes r, an int array in size, the number of elements. Then it loops and adds up the values and returns the average. Notice that every function that takes an array also takes a size parameter. Inside the function, Sysioff r does not give the array size. It gives the size of a pointer, which we will explain in a later chapter. When you call the function, you write just the name, scores, with no brackets and no size next to it. The brackets only appear in the parameter list. And remember, always pass the size yourself. This is the most common array bug of all, the off by 1 error. In this loop, the condition is I less than or equal to 5. That looks reasonable, but it is wrong. The array has indices 0 through 4. The condition lets I reach 5, which is one past the last valid index. So the loop runs 6 times, and on the last pass, r at 5 reads memory past the end of the array. That is undefined behavior. The fix is to use I less than 5. Memorize this pattern once and for all. For int I equals 0, I less than size, I plus plus. Always less than, never less than or equal to. Let's recap. An array is a fixed size sequence of elements of the same type, stored one after another under a single name. You declare it with square brackets, like int scores square brackets 5. The indices are 0 based, so scores at 0 is the first element and scores at 4 is the last. You iterate with a for loop, I from 0 while I is less than the size. Always less than, never less than or equal to. Remember, C does not check bounds. Reaching outside the array is undefined behavior, not a friendly error. To count elements, use Sysioff array divided by Sysioff array at 0. And when you pass an array to a function, always pass the size too. Next, you will learn multidimensional arrays, which are tables with rows and columns, like a spreadsheet or a game board.